Hi, today I'm going to go over some basic problems that deal with writing functions in C. So whether you're just learning the language by yourself or if you're doing it in school and you have a test coming up or an exam and you need to study, this video may help you. So I have an exam coming up in a class right now where I'm writing programs in C. So you can count this as my studying. So me doing this video while doing these problems, that's killing two birds with one stone. That is efficiency. So let's begin. So we're going to write a function that takes an integer n as input and displays the sum of integer numbers from 1 to -1. So, for example, and if we have n is equal to 5, our output is going to be 10 because 1 plus 2 plus 3 plus 4 is equal to 10. We're excluding 5 because it goes up to n minus 1. So I encourage you to pause the video and try out the problem yourself, and then when you're ready, you can resume, and then you can see how we do it. So I'm going to start. So right now the question doesn't say anything about returning anything, so we can assume it doesn't return anything, which means it's a void function. So a function that says void means it returns nothing. So I'm going to call it sum up to n, int n, and I'm just going to declare it like that, semicolon. I'm declaring the function because in C, you have to declare the function first and then write what the function does afterwards. Otherwise, whenever you try and run the function, it's going to be implicitly declared. It's going to be implicitly run, and C does not like that. So we have to do it this way. So here we go. We're going to have a sum variable, just like that, to store our sum. So we're going to also have a for loop, and we're going to set the counter at 1 because we're going to be adding, the idea is to add I to sum up to, but not including n. So we're going to start with 1 because why would you include 0? Because if you're just adding 0, then you're just wasting time. So I is less than n because we're not including n. I plus plus, we're just incrementing I. And all we're going to do is we're going to say sum plus equals I. We could have also wrote it like this if you wanted. That's perfectly fine. I'm writing it like this because it's quicker. And then we're gonna return. We're gonna not return because we don't return anything. So we're gonna print the value, and the value is gonna be sum. So let's say, so I have to run the function. I have to run it. So I'm gonna go sum up to n. I'm gonna run 5. Basic. So a little tip: whenever you're given a question and it gives you an example input output, so it gave us an example with 5, run the example input output. That way you can tell if it matches, you're good. So when we run, we get 10, it matches, so we're good. And if we put 10 from front in here, we should get 45, and voila, we get 45, so we're good. Next problem, we're going to write a function that takes an input as integer. No, we're going to take another integer number n, display all the positive factors of n excluding n itself, and returns the sum of them. So we're displaying in the function the factors. So if n equals 12, we're displaying 1, 2, 3, 4, 6, and excuse me, we're going to be returning the sum of all of these values, which is 16. So same thing, we're returning something, so we're going to be returning an integer because the sum of integers is going to be another integer. So int factors, and we're going to pass the same value, and I'm going to copy paste because now I gotta define what the function actually does. Same thing, I'm going to declare some variable. The same thing, I'm going to make a for loop that runs at 1. Now we could go I is less than n, I plus plus, because, you know, we could do that, but there's a way we can make this a little bit more efficient just by using a little bit of logic. So notice we're not including n itself as a factor. So what we're going to do is we're going to look and see, just by knowing that the largest factor there is for a value, excluding the value itself, is half of, or could be half of the value. So the largest possible value is 6 when n equals 12, because 6 times 2 equals 12. 12 divided by 6 equals 2. So we're right at the halfway mark. So we only have to go up to n over 2. Just like that. So sum, we're gonna, oh wait, we have to validate first. Is I, we're gonna be checking I, is I is n divisible by I. So how do we do that? We use the modulo operator, which is a percentage. So if we're going to do n divided by I is equal to 0, basically meaning when we divide n by I, do we get a remainder of 0? Meaning, is there no remainder? Meaning, is it divisible? If so, then we can add I to that, and we can print the value. I'm just gonna print with a space, and then not sum, I, just like that. And then at the end, we're going to return the sum, and that's it. So we have declaring the sum variable. We have this for loop that goes up to half of the value. Then we're checking if whatever value in the for loop, if n is divisible by that value, then we're adding it to the sum and we're printing the value. So I'm going to run the function factors 12 again using the same sample input output. 1 2 3 4 5 6. Oh, I forgot to print. So I forgot to print values, just like that. I just have to do that. 1 2 3 4 5 6 16. The sum is 16, so we're good. If I did a prime number 5, 1. We're not including 5, so it's just 1. So we're good. Next problem we have: write a C function that takes two input parameters, an array of characters. One of them is an array of characters or a string, because a string in C is an array of characters, and its size as an integer, and it's going to return 1 if the first character of the given string is in uppercase, returns 0 if it is lowercase, and returns -1 if it's just a digit. So this is a mean question to ask on exams. Why? Because you need the ASCII table, which we're going to go over later. So I have this. I was testing something before, so let's get rid of that. C function. So since we have it returning something, we know it's going to return an integer. So we'll call it check first char. We're going to have a char array. We're going to call it str just for string, and int l for length. And we're going to copy and paste, because you know what? You can't go wrong with a little copy paste as a programmer. So what we can do is, to get the ASCII value, a simple thing we can do is we'll call it num. We'll just take the first character and set that as an integer number. Now we have to reference the ASCII table, which, doing some Google search, ASCII table in C, we get this value. It's probably small print for you guys watching, but we see that the range of capital letters is 65 to 90. So what we want to check is we want to check if the number is greater than or equal to 65 and num is less than or equal to 90. Basically, if it's in that range of capital numbers, then what we do is just return 1. Else if now we have to check if it's lowercase numbers, lowercase letters. You can't have lowercase numbers. At least I don't think. If someone invents that, please let me know. That's going to be 97 to 122. So we're going to go from 97, same thing, 97, and num is less than or equal to 122. And we're going to return, this time we're returning 0. Last thing, we're going to interpret this digit as something. So returns -1 if it's a digit. If it means a numerical digit, then we'd have to check the ASCII table and it would be 48 to 57. But this function has to return something. If it's not, because what happens if it's not a character at all and it's not a digit? So what I'm just going to do is I'm going to interpret it as just any other character. So a basic little tip about writing functions is I don't have to write an else statement. Why? Because right when the return statement is run, then the function stops. Like, it doesn't check anything else. The function's done. When it runs 0, the function's done. So it's never ever going to get to this -1 if it's a capital number, lowercase number. It's never going to reach -1, so we don't have to worry about it. So we could just paste it out here. We don't have to do it else. You can do it else if you want to, but it's pretty much useless. So Notice that the length isn't really used at all. It's beautiful. First character, because it's all about the first character. So we're gonna print the value that it gives us. Printf d, and then check first char. I'm gonna say hello, and that's length. That's length 6. So it should give us 1. There we go. That's why I didn't see. So it gives us 1 right here. So we're good. Now, what if it's a lowercase number? What if it's a lowercase? So if it's e, 0. I forgot to change the length. Uh-oh. That matters so much. 0. If I do a character, we're going to get -1. If I get a number, it's going to be -1. So we're good. So we're going to go problem 5. Problem 4. Oh, I put 5. Oh, well. Write a function that takes an integer as input and returns the sum of all of its digits. So we're going to write a function, so we're returning something. So integer, returning an integer. Sum of digits int n. Basic little thing right there. Again, programmers love copy paste. Stack Overflow. No. Not in this case. We're going to write it authentically. So what we're going to do, we can have our sum variable just like we always do. If sum, int sum is going to be equal to 0. Now we're going to run. We don't need a for loop actually. We could do while. We're going to do a while loop this time because we're not iterating it for a known number of times. So we're going to go while n is greater than 0. Because what we're going to do is we're going to do a little trick with integers. So the sum is just going to be n mod 10. Well, why? Well, what is so special about this? So let's say n is equal to 123. So 123 mod 10 is going to be 3, because when you divide 123 by 10, your remainder is 3. Then what we're going to do is we're going to go n divided by equals to 10, or we could do n divided by 10 like this, but that takes longer to write, so I like this better. So what this is doing now is when you do integer division by 10, all it does is, I didn't mean to write that slash, gets rid of the last digit. So the mod 10 returns the last digit, it gives you the last digit of the integer, and dividing by 10 just gets rid of the last digit. And then we do it again in the loop, and we get a 2, and divide by, so we get 1 now, and now for our last digit is 0, 1, and then 1 divided by 10 for integers is going to be 0. And then n is not greater than 0 anymore, so that's it. Return sum. So let's see if we can trust this. So I'm going to print, this time I'm going to make it a little bit more clear with myself, so I'm going to new line character. Sum of digits, let's go with 123. Oh shoot, I made a mistake. So I want to add the value. So I'm going to go sum plus equals n mod 10. There we go. Little boo-boo. Oh well, we all make boo-boos. So, because it's 1 plus 2 plus 3 is equal to 6. Let's see if I add a 4th digit here. We should get 10, and we do. 5, 15. If I change the first digit, let's say I make it an 8, we should get 18. 22. 8, 10, 13, 17, 22. There we go. Can't do mental math. It's tired. I'm tired. Okay. Last value. Write a program to read input values from an integer array of size 15 and display the second largest integer value in the array. So we're going to pass an integer in a function. So we're displaying something. Doesn't say anything about returning, so it's a void. We'll call it second largest. We're going to have it a integer array. It's an int array, so we're going to call it int r15. That's it. So in our function, what we're going to do, we're going to need 2 variables. We're going to need a largest variable. Int largest is going to be, we can just declare it to the first value. Int second largest Oh, and we actually can't call it the same thing. So I'm just going to call largest 2. I was going to call it the second largest by accident, but you can't call a variable the same name as the function itself. So we can call it array 0 again. Now we're going to loop through. Now normally in for loops, whenever we're dealing with arrays, we're going to go with 0. But the thing is, we already declared them as 0, so we don't need to do that. So we can just go with 1. I is less than 15. I plus plus. Remember, less than 15 because the thing about arrays is, while the length is 15, there is no value at index 15 because that would mean that there's 16 values. End curly brace. Don't want a curly brace error. There we go. So what we're going to do is we're going to check if array at I is greater than the largest value. So if it's larger than the largest, then what we're going to do is we're going to say largest 2 is equal to the largest. So now largest 2 is equal to the old largest, and largest is now equal to the new largest, array at I. Else if, we can have an else if statement that says array at I if it's greater than the largest 2. If it's just greater than largest 2, and array at I is less than or equal to the largest 1. Basically just saying like it's larger than the second largest value, but it's not larger than the largest value. So then what we could do is just largest 2 equals array at I. That's it. And all we're going to do, we're going to display the second largest value. So we're going to printf new line. I like new lines. It's awesome. Largest 2. Just like that. Now we have to run the function. So I'm going to first declare an array. I'm going to declare an array 15. Let's go something basic. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And I'm going to run it. I'm going to put array in here. Just like that. Let's see what happens. We get 14. There we go. Now what if I put 14 here? What if I put 15 here? And then 14 there? 1, 2, 3, 4, 5. Let's make this -5, -9. Why not? So we should get 14, and we still get 14. What if I make it What if I make it? What if I make this 16 or 178? Why not 178? I did a typo, but oh well, still works. At 145. That was not a typo. 145. Notice we get the second largest value. If I got rid of this else if statement right here, if I get rid of that, then watch what would happen. We get 5. Because it wouldn't have accounted for this is greater than the second largest, which is 5, but it's still not greater than the largest, so it doesn't do anything. So we need that else if statement there. Okay, so that's 5 problems with writing functions in C. I hope you found these helpful. If you're just learning for fun, then I hope you had fun. I hope this was fun for you. And if you're doing this because you're studying for an exam, I wish you good luck with your exam. I wish you all the good luck. Thank you so much for watching, and have a good day.